Okay. Do you have pen and paper along with me? Along with you? Do you have pen and paper along with you?
Yes, sir.
Sir,
Okay, okay, okay. Okay, so in our previous derivation, whether am I audible? Am I audible?
yes,
Yes,
sir.
sir.
Okay. So in our previous class, we have derived the equation for the stopping side distance. So that stopping side distance was Vt plus V square divided by 2GF. So here one thing you can notice that the V in that equation that was in meter per second. But often in the numericals, what happens? Your V would be given in kilometer per hour. Okay, so for that reason, what you have to do? First, you have to convert that V into meter per second, and then you can proceed with the normal equation. Or otherwise, there is another equation is provided. In that equation, already whatever V is there, it is already converted to V kilometer per hour, and a final equation is provided. So you can write that equation. So in that equation, your stopping side distance, it would be, just write it down. Your stopping side distance would be, that is SST. Just simply write SST equal to 0.278, 0.278 capital V, capital V. The previous one was small v, capital V plus, sorry, capital V into T, that is V into reaction time, Vt, plus capital V square divided by 254F, 254F.
Sir, you're sharing your screen because it's not visible to us.
Hello, can you repeat?
The screen is not visible to us, sir.
Actually, I'm not sharing the screen. That's why. Have you written that formula?
Sir,
Okay. Just a minute. In that case, it would be easy for you. Is it visible? Some book is there. Is it visible? Hello?
sir.
Is it visible?
Yes, sir.
Okay. See, this is the formula. Okay. Your SSD equal to 0.278 into V, capital V into T, divided by V square divided by 254F. Okay, this is your formula. So in that formula, if your V is in kilometer per hour, so you do not need to convert the V. You can directly go with the V, whether it is in kilometer per hour. Okay, or if you want to go for a normal equation, that would be easy to remember. In that case, you can go with the previous equation, that is Vt plus V square divided by 2gf. Okay. Now another thing, you remember, I think, that I've said that longitudinal coefficient of the friction will depending on the speed of the vehicles. So there one table is there. You see the table where speed and longitudinal coefficient of friction value is given. Is it visible? That is for 20 to 30 kilometer of speed, your coefficient of friction value is 0.40. Like that, one table is given. Just write this table also. That is also important. Okay. Now coming to the numerical. So this is your numerical. Write down. Calculate the safe stopping side distance. Calculate the safe stopping side distance for design speed of 50 kilometer per hour for two-way traffic. Two-way traffic on a two-lane road. On a two-lane road, and B, two-way traffic on a single lane road. Here it would not be plane, it would be lane. It would not be here. Okay, single lane road. Now, can you tell me how we will find out this stopping set distance for this numerical? So first is you have the equation. Okay, your stopping set distance equation was Vt plus V square by 2gf, or the second equation. So if you go for the first equation, that is Vt plus V square by 2gf, in that case your 50 kilometer per hour. Okay, so you need to convert that 50 kilometer per hour into meter per second, and you can proceed. And first, you need to convert this, and it will be coming around 13.9 meter per second. And after that, you put all the values. Okay, so here your equation is Vt plus V square by 2gf. Here t, the value of t is 2.5 second. Okay, that is the reaction time which you have considered. Now, F is the coefficient of friction. Now this coefficient of the friction value we get to know uh, from this table. Okay, here your design speed is given as 50 kilometer per hour. So for this reason, that f is considered as 0.37. So your stopping side distance is your this v into t, that is the reaction time, divided by v square by 2 into g is gravitational acceleration into 0.37, that is 61.4 meter. Okay, just write it down, 61.4 meter. Now, if you want to go with the second equation, in that case, that is the second equation, you can directly put the 50 kilometer per hour over here and you will get 61.4 kilometers. So, in one step, you will get the answer. But here, first you need to convert and then you have to proceed. So, it is up to you which equation you want to remember. So, have you noted it down? Have you noted it down? Okay. Uh, Now again, see one thing, that your question, the main question was you need to find out the stopping side distance for two-way traffic on two-lane road. So in a two-lane road, there is sufficient spaces provided. So if it is two-way traffic in a two-lane road, in that case, whatever stopping side distance you have found out, that is the final answer. Now, the question number B was two-way traffic on a single lane road. Now, if it is a single lane road, you know the width of the single lane road is 3.75 meter and width of a particular vehicle is generally considered as 2.5 meter. So in that case, what happened if some obstructions appears in front of the driver? In that case, driver will need a greater distance to stop the vehicle. Okay, because he cannot pass through it. Okay, or he cannot eliminate the obstruction without stopping the vehicle. So in that case, if it is two-way traffic and single lane, your stopping side distance will be 2 into whatever stopping side distance you have found out for two-way two-lane road. Okay, so 2 into your stopping side distance, that is 122.8 meter. That would be your final stopping side distance for two-way traffic on a single lane road. So is it clear? Is it clear?
So
Hmm. Is it clear?
Yes, sir.
Okay. If it is clear, then solve the next problem. And after solving the problem, you just write the answer in the chat box. I think next problem is also feasible. Calculate the minimum sight distance required to avoid head-on collision of two cars approaching from the opposite direction at 90 and 60 km per hour. Assume a reaction time of 2.5 seconds, coefficient of friction of 0.7, and brake efficiency of 50% in either case. Now, before proceed to the numerical, one thing you just note down. See here, coefficient of friction value is given as 0.7. Okay, it is given as 0.7, and the brake efficiency is given as 50%. You know that brake efficiency and coefficient of friction will work along with each other. So in our previous case, our brake efficiency we have for the numerical purpose we have considered as 100% as it was not mentioned. So whatever coefficient of friction value was given or we got from the table, we just directly use that portion. Okay. Now, in this case, the coefficient of friction value is given as 0.7 and brake efficiency is given as 50%. So, as it is 50%, so therefore, ultimately, that coefficient of friction value, okay, you will divide this coefficient of friction value by 2, or you can 0.7 into 0.5 because of the 50%, and you will get a coefficient of friction value of 0.35, because in your equation, that is the stopping side distance equation, there is no any component in which you can put the value of efficiency of brakes. Okay, so for this reason, you have to multiply this coefficient of friction value with brake efficiency value with for ultimately getting the ultimate coefficient of friction value. Okay, so your coefficient of the friction value would be 0.7 into 0.5 or 50%, that is 0.35. So you get a coefficient of friction value of 0.35, then you can proceed with the numerical. So this is your first step. First is you need to find out the coefficient of friction value. Next step is you need to calculate the stopping side distance for uh, both of this speed, for both of these vehicles. Okay, for individually you have to calculate the stopping side distance. So first you need to calculate the stopping side distance for 90 km per hour speed, and second you need to calculate the coefficient of friction value for 60 km per hour speed. So just calculate. It's very simple. Just you have to put all these values in the equation and you will get the SHD value. If you got the value for 90 kilometer per hour, I need some answer. Have you got the value for SHD for 90 and 60 kilometer per hour? See, I think you have made some calculation mistakes. First, convert the speed if you have used that formula for 90 kilometer per hour. You will get this one. That is 153.6 meter. So basically, if you are using this formula, that first formula, that is Vt plus V square by 2gf, in that case you need to convert that V. Okay, so in that case your V would be 90 kilometer per hour, so it would be 90 into 1000 to make it meter divided by 3600. Okay, to convert the hour into second. So it is ultimately 90 divided by 3.6 is equal to 2.5 meter per second. And for the V2, it would be same 60 into 1000 divided by 3600. So ultimately it would be 60 divided by 3.6, that is 16.67 meter per second. So then after you can proceed. Okay, so your Vt plus V square by 2gf, you got this SHD for vehicle 1, and for the second car you will get this equation. So ultimately that side distance is required to avoid head-on collision would be 153.6 plus 82.2 meter, that is 235.8 meter. That is your ultimate SHD. Please note it down. So these two are the two type of questions which may appear, and another one is another type of question may come, that is you have to calculate the stopping side distance for any ascending or descending gradient. So in that case you just have to modify your formula, that is f plus minus n%, and you can easily get the equation. So this is all about the today's class. I'm not starting any other new topic to this class. So in our next class, we'll read about overtaking side distance. So you can leave the meeting. I think you have noted down this numerical. So I am ending the meeting.